Okay, so our last topic for finals will be all about the filter network. So basically, ang pag-uusapan natin dito would be this 4 basic type of filters. Itong low pass, high pass, band pass, and band stop filter. Okay? So, ayun. We'll talk about that one by one. So sa filter networks, meron tayong tinatawag na attenuation. Pag sinabi nating attenuation, it is a reduction or loss in the magnitude of the voltage or current due to its transmission over line. Okay? Pag sabing transmission class, the reduction, kumbaga instead of 5 volts, naging 3.8 na lang siya, naging 4 volts na lang siya, ganun. Okay? The loss in magnitude. Usually, class, yung attenuation happens, no, kapag ka, for example, yung voltage or yung signal travels in a long line. Usually, meron talagang attenuation na nangyayari. Okay? So, yun yung attenuation. It is the loss in magnitude. Okay? Ang filter class, a filter is a network designed to pass signals having frequencies within certain band called bandpass with little attenuation. Kasi meron siyang kumbaga frequency. Kapag ito yung signal class and then merong certain frequency na papadaanan niya with little attenuation. Ibig sabihin, nababawasan yung signal, yung voltage or yung magnitude ng signal, onte lang. Okay, little attenuation. But, meron din naman kapag meron din namang other frequency na yung signal is ina-attenuate niya. Okay? Ibig sabihin, masyadong mababa na yung output ng iyong voltage kasi nga in-attenuate niya na. Ang tawag mo dun sa mga signal na yun is the stop bands. So, if you try to titingnan mo siya sa graph, parang ganito. So, say for example, this is in terms of frequency. Okay, di ba sabi kanina meron tayong, for example, on this line, okay, for example, itong first, sabi niya, with little attenuation. For example, from here, from this frequency to this, tawagin natin itong FC. From this frequency to this, yung ating signal is attenuated siya. Okay? So, parang ganito. Attenuated. So, kapag yung frequency na dumaan sa iyong circuit or sa filter is nandito siya in between this, na-attenuate siya. Kapag ka naman from here up to infinity or papunta na doon, hindi niya na ina-attenuate. Okay? So, ibig sabihin, yung filter na to up to this frequency, itong region na to, is pinapass niya. Kaya ang tawag natin dito, sa region na hindi niya ina-attenuate, is ito yung tawag natin na pass bands. Okay? And on this part naman, this is what we call the stop bands. Kasi parang in-stop niya to, 'di ba? Kasi in-attenuate niya, tinatanggal niya yung signals kumbaga. And in here, pinapalampas niya yung signal, that's why it's called pass bands. Okay? So, between the pass band of a filter, where ideally attenuation is 0, so ideally class dito yung attenuation natin is 0. Okay, hindi niya ginagalaw yung signal. And the attenuation band, where ideally the attenuation is infinite, ideally din naman yung attenuation natin dito is infinite. So between them, we have it here. This is what we call the cutoff frequency. That's why it is called FC, frequency cutoff. Okay, ang tawag natin dito cutoff frequency. Kumbaga ito yung margin or kung saan nade-divide yung dalawang region. So lower than this, you have attenuation. Higher than this, you have zero attenuation. Okay? So this being the frequency at which the attenuation changes from 0 to some infinite. Right? So that is the terms that you have to be familiar with when it comes to filters. Okay, next. So may mga filter class na meron siyang source or power. Ang tawag natin doon ay passive. Okay? Kapag ka meron siyang source or power. Kapag ka naman, kapag ka walang source rather. Kapag ka naman may source, ang tawag natin dyan is active filter. Okay? So, ito na yung 4 filters na i-discuss natin. We'll talk about this one by one. Another terminologies with the two-port networks and characteristic impedance. Plus, pagka sinabi natin two-port networks, ibig sabihin, these are it is a network wherein yung electrical energy natin is fed at one pair of terminal. Kumbaga, meron kang isang pair. Say, for example, meron kang circuitry dyan and this one. This is called two-port network. Kasi yung electrical energy is fed at one pair of the terminals. So, andito yung input natin. Ito sa isang pair. And your output is taken out sa another pair of terminals. Okay, this one is called a two-port network. So in here, we have an example of yung two-port network na sinasabi natin because if you notice, you have here two pairs of terminal. So input is fed here, then output is taken here. Okay? Same is true dito. Class, so if you notice sa ating circuit before, ano ang tawag natin sa circuit na to? This one is called T network, di po ba? And this one is called pi network. Remember? T kasi yung form niya as of T. This one naman is para siyang pi. So, pi network, T and pi network. Okay. So, class, sa T and pi network, meron tayo ditong, ano, ayan. Wait lang. So, the figure 17.8, so, and on this figure class, it shows a T network, which is termed symmetrical. Yung T network na to class, it's symmetrical if yung Z, this one, and this one are equal. Okay? So, bakit siya naka-rectangle? It's either, it could be any element. Pwede siyang resistor, pwede inductor, capacitor, it doesn't matter. Okay? So, as of the moment, tawag natin sa T network na to is symmetrical if Z is equal to B. If this one are equal. Dito naman sa kabila class, this one is also called symmetrical if E is equal to F. If eto siya ay equal to dito, symmetrical. Shade natin kapag yan at saka yan ay equal, symmetrical. This one naman, and this one, is symmetrical. Right? So, if this one is not equal to this, and ZE and ZF is not equal, ang tawag natin sa kanya, of course, is asymmetrical. Okay? Those are just the terms that you have to remember. So, symmetrical kapag equal, asymmetrical kapag hindi. So, class, in this network, both networks na pinapakita dito, meron common terminal. Diba? This one is the common terminal sa network na to. Hindi po ba? Common terminal. This one is common. Kapag ka ganun class, meron siyang common network at saka pwede siyang i-ground or earthen. Ang tawag natin dyan is unbalanced. Okay? Tawag natin dito is unbalanced kasi meron siyang common terminal. Okay, ito naman class, itong figure na to, this is what we call, ito naman yung itsura kapag ka meron kang balanced T network. T network siya, pero meron siyang something here, so as if wala kang common terminal, ano? So this one is balanced T network, this one is unbalanced T network. Balanced. This one is unbalanced. So, ano na lang, mnemonics niya, kung titingnan mo, ano, sino bang mukhang balance sa kanila between the two? Diba this one? Oh, this one is balanced. This one, sino bang mukhang mas balanced? This one. Oh, this one is balanced. Unbalanced. Basta ang talandaan, unbalanced is meron kang common network or common terminal na pwede mo siyang i-ground. Start with the first type of filter. We have the low-pass filter. So, ang low-pass filter class is designed to pass signals at frequencies below a specified cutoff frequency. So, remember kanina, kung ito yung attenuation, ito yung frequency, di ba, meron kang hati sa gitna. This is what you call the cutoff frequency. Low-pass mo siya class, ibig sabihin, at lower than the cutoff frequency, this is the pass band. Okay? Higher than the cutoff frequency, this is your attenuation band or stop band. Or dito, yung signal mo is na-attenuate. Okay? So, kung titingnan mo siya class, para siyang ganito. So, diba sabi kanina, ideally, this should be 0. 0 dapat ang attenuation, ano? But then, in real life, that doesn't happen. So, meron kang a little bit of attenuation. And in reality class, kailangan straight na to agad. Tapos, ganito na siya. I mean, in ideal, di ba? Kasi nangyari dito, although lagpas na siya ng cutoff frequency, meron ka pa ding attenuation. Tapos, paunti-unting nawawala yung attenuation. So, because this is the practical, okay? This one is not ideal. But ganito yung ano niya, ano, if you notice, saan nag-attenuate sa low pass, dito sa higher frequency. Magbaba ang input signal, the magnitude of the input signal, magbaba siya din because low pass man siya. Kinsa yang paagion, mga low frequency. Low, sa atong basihan, sa iyang pagka-low frequency, kani atong cutoff frequency. Below that, paagion niya, mabitang tawag niya is pass band. Higher than that, is attenuate niya, that's why what we call the attenuation band. Okay? So this is the symbol for your low pass filter. So if you notice, so, you just have to, ano na lang, no, parang literal masyado yung kanyang symbol. You have two frequency, higher and lower. Kaya nasa taas, nasa baba. Wala niya gipag si higher, then this one is a low-pass filter. Okay? So, yung low-pass filter, sometimes it is, yung mga filters actually kasi is made up of reactive elements, made up of inductors and capacitors lang sila. Alright? So we have here, this could be the circuit for your low pass filter. You can have it like this. So in terms of T network, pwede mo siyang i-implement na ganito. You have your inductor, capacitor. For pi network, ganito siya. Okay? So, para matandaan mo lang, mnemonics lang kapag how would you know na, okay, parang low pass filter to, parang high pass filter to. You can see it as, kumbaga itong inductor, binablock niya si high pass filter, high frequency signals. Okay? So, kay first na, siya may una na tagbuan, so imo ang high frequency signals, na-block na. Okay? Kisa lang makalusot, mga low frequency, thus low pass siya. Okay? So, in here, dito pa lang, na-block na si high pass sa high frequency. So, dito, low frequency na lang natitira. So, para lang matandaan mo lang yung circuit. But this has, pag merong in-depth na discussion dito, nade-discuss talaga to kung paano niya na filter yung iyong signal. Okay? So still you have here your circuit for your low pass filter. This is again sa T network. This is if implemented siya sa pi network. So class, this is L over 2, L over 2. Just to ensure, kasi we are aiming for symmetrical networks. Diba pag symmetrical, kailangan ito equal. And this one is also equal. Remember that. So na ba yun? Remember this, diba pag symmetrical, kailangan ito ay equal at saka ito ay equal. So in here, just to ensure na equal sila, this one is labeled as L over 2, L over 2. Okay? This one naman, this is C over 2, C over 2. Okay? So don't be shocked. Ayun. So, this is your RO, this is your output impedance. So when the frequency is very low, the characteristic impedance is purely resistive. Kapag low yung frequency sa iyong low pass filter, di ba, it doesn't attenuate the signal. So this value of characteristic impedance is known as the design impedance or the nominal impedance in the section open given as the symbol RO. So yung RO mo would be this one, square root of L over C. Yung FC naman class, kapag ganito yung circuit mo, kasi na-identify naman yung values ng iyong cutoff frequency, depende sa yung values ng inductor and capacitor. And yung formula natin sa low pass filter is this one. FC is equal to 1 over pi over square root of LC. Paki-take note po itong dalawa. Alright, so let's have here numerical example. Problem 1. So determine the cutoff frequency and the nominal impedance for low pass filter T-connected section below. So this is your figure. You have your T network. Hanapin daw natin si cutoff frequency and si nominal. Ano nga ulit yung formula ng ating cutoff frequency? Diba FC sa low pass filter is equal to 1 over pi square root of LC. Okay? So yung LC class, remember, wait, balik natin to. Kapag ganito siya, T network, ito yung C. Yung L natin, andun pa, hanapin pa natin. Ito naman, yung L natin, ito na yung C, andito pa sa taas. Okay? Okay. Okay, so look at the figure class. Diba this one class is L over 2? This is also L over 2. So based on the figure, your L over 2, yung L over 2 mo ay ito, 100 millihenry. Plus, kung dito ka sa kabila titingin, same lang din naman, because this is L over 2, this one is also 100 millihenry, sorry. So, ayun. So, we now have, cross multiplying this, your L is equal to 200 millihenry. So, nanatay L. Next, we're looking for C. So, C class, kaya siya lang man isa, that is your C na. Your C is 0.2 microfarad. So, given that, of course, your FC is now equal to 1 over pi square root of 200 milli times 0.2 micro. Pause the video class and kindly calculate. You should get FC of 159.2 na lang. And this is in terms of hertz. Okay? Or our FC is equal to 1.592 kilohertz. Thus, that is your FC. Next, we're looking for RO, nominal impedance. So, ano nga ulit yung formula ng ating RO? RO is equal to, kapag low pass filter, square root of L over C. Purely substitution, kasi nahanap na natin si L at saka C, or L is it's 200 milli, your C is 0.2 micro. So, yung RO natin, class, would be, kindly pause the video and calculate. This is square root of 200 milli, 0.2 micro. You have 1,000 or 1K ohms. This is your RO, right? So, it's the same with the solution here. Okay, so that is for your low-pass filter. So, second type of filter, we have the high-pass filter. A high-pass filter is one designed to pass signals at frequencies above the specified cutoff frequency. So, cutoff frequency, above that, it could pass the signal. It doesn't attenuate. So, kaya ang tawag dito pass band. This one is attenuation band. So, in practical, ganito yung magiging circuit natin. FC and below, meron kang attenuation. FC greater than that, you don't have attenuation. Okay, meron kang a little bit of attenuation because this is not ideal. So, this is how the circuit is done. Meron kang capacitors. If T network siya, ganito. Kapag pi network ka, ganito siya. So, if manotice mo, kung yung circuit kanina, wait lang. The circuit kanina, sa low pass filter, si capacitor yung naka-shunt or naka-parallel. Okay? Sa high pass filter, si inductor yung naka-shunt. Okay? So, yun na lang yung tatandaan mo. Isa sa tatandaan mo. And when it comes to figure or symbol, you have higher and lower frequency. I-block mo niya sa low frequency. So, malaman, this symbol is for high pass filter. Okay? Okay. So, yung cutoff frequency natin, class, and nominal impedance, mag-iba na yung formula ng yung cutoff. So, kanina, that's 1 over pi square root of LC. So, ngayon, yung cutoff mo, frequency is 1 over 4 pi square root of LC. Paki-note na sa notebook. Yung RO mo, still, you have the same. And, this is your figure. Okay? Again, si high pass, si inductor naka-shunt. Kasi we are looking for we are assuming that this is, or it is really symmetric circuit network. Kailangan ito 2C siya, class. Same sila ng value. Ito naman the same. So, kanina, sa low pass, di ba this one is L over 2, L over 2. Sa high pass, class, you twice it. I mean, you times 2. So, this is 2C, this is 2L. So, this would make sense kapag meron na tayong example. You have it here. Sabi dito, so we have here example for high pass filter. So you would know na high pass siya kasi si inductor yung naka-shunt. Okay, sabi dito, determine the cutoff and the nominal impedance. So solution, yung cutoff natin, FC, yung formula is 1 over, because high pass, so this is 4 pi square root of LC. Hanapin muna natin si L at saka C. Again, class, if you could remember, kanina meron tayong ganito. Kapag ka ganito, this is T network. So, ito na yung L natin. And yung C natin, we will call this 2C, itong capacitor. So, meron din tayong 2C. Plus, kapag pi connected siya, this is your C, this is 2L, itong sa gilid. Tandaan nyo lang. Okay? So, yung L natin, automatically, this is now 100 millihenry. Yung C natin, class, di ba 2C is equal to, 0.2 microfarad. So, your C is equal to 0.1 microfarad. So, na kay L og C, then, substitution na lang, class. This is 1 over 4 pi square root of your L is 100 milli, your C is 0.1 micro. So, your FC, kindly calculate, is equal to 1 over 4 pi square root of FC is 796 hertz. Okay? So next, we're looking for RO. Yung RO natin, ang formula is square root of LC, which is equal to, ang L natin is 100 milli. Your C is 0.1 micro. So, ating RO would be equal to square root of 100 milli over 0.1 micro, 1 k ohms. Okay, so that is your example for your low-pass filter. So, the third filter is we have the band-pass filter. So, ang band-pass filter, basahin niyo na lang to. Okay? But based on this figure, ganito siya. If you have here your frequency, so kanina meron ka lang FC. So, ngayon, meron tayong dalawang frequency. FC high, FC low. Baliktad no, diba? Dapat ito yung FC low, dito FC high. You would know later. Okay? Basta meron kayong FCL, FCH. So, parang ganito siya. Kasi dalawa yung cutoff mo, madadivide siya into 3 region. Itong gitna class, ito lang yung ipapass niya. Ito lang yung pass band mo. So, ito lang yung frequencies na hindi siya mag-attenuate. Less than that, or prior to that, attenuate siya. Pag maglampas ba siya din sa PCAS, attenuate pa siya. Okay, that is your band pass filter. Now, like certain band nga ginapass niya. So, in practical, ganito yung magiging itsura niya. So, on this, kasi attenuation band to, meron kang attenuation. Dito naman sa band pass mo, meron kang a little bit of attenuation. After that, meron ka na namang attenuation. Okay? So, when it comes to circuit diagram, ganito siya. You have your para meron kang tatlong signal dito sa gitna. In between the two, ito lang yung papalampasin niya. Ito lang yung pass band mo. Before, and lower than that and higher than that, it's attenuated. Okay? So, paano ba ginagawa itong bandpass filter? So, if you notice mo class, if titingnan mo siya, eto, look at this. Kapag ganito lang yung tingin mo, di ba para siyang, tawag mo dito, kapag ganito yung graph, para siyang high pass filter. Right? Kapag titignan mo na naman siya dito, para siyang low pass filter. Correct? So, ibig sabihin, that gives us an idea on how to create this type of filter. So, itong mga filter na to may be formed by cascading. Ibig sabihin, i-connect mo siya. Cascading your high-pass filter. Kasi kapag ganito, di ba, that one is high-pass? Yes. And a low-pass filter. Yung FCH is the cutoff frequency of the high-pass filter. Kaya nga H to class because kaya to H because it's for high-pass filter. This is H because parang this is the frequency for your low pass filter. Okay? So we'll have example. So this is our example for band pass filter. So we have here our problem. A band pass filter is comprised of a low pass T section filter having a cutoff frequency of 15 kilohertz connected to a series high pass filter having a cutoff frequency of 10 kilohertz. Terminating impedance of the filter is 600 ohms. Determine the values of the components comprising the composite filter. So for this type of problem, we're required to look for our L and C. L and C values such that meron kang band pass filter na merong cutoff frequency na 10 to 15 kilohertz. Other than that, or outside the band, it would attenuate the signal. And given ang ating impedance na 600 ohms. Okay? So if you try to draw the circuit, it would look like this. Diba? Kasi si band pass is just a combination of your low pass and high pass. So this one, diba pag naka-shunt si capacitor, that is your low pass filter. So low pass lang siya. And then cascaded siya with the other filter. Again, pag naka-shunt si inductor, this is your high pass filter. Okay? Now we're going to look for these values. This is unknown. However, we are given with our frequencies na 15. Yung 15 natin, that would be our low pass. So our FC low is equal to 15 kilohertz. Our FC high is given 10 kilohertz. Okay? So, this is for low pass, this is for high pass. Given siya, and given din ang ating 600 ohms, that is your terminating impedance or your RO. RO, which is equal to 600 ohms. So these are our given. And another thing that I forgot to mention is that if your output impedance here is 600, you would also have here 600 because that is termed as, I think, iterative impedance. Na kung ganito siya, 600 dito, then you're gonna have 600 here. Okay? So let's start solving this one. So I think we can start you can start here. Dito na lang sa low pass. Again, class, if this is 600, this is also here 600. So given na din yung, as if given na din yung RO natin dito. Okay? So solving our low pass filter, sabi sa low pass, our formula, di ba si FC is equal to 1 over pi square root of LC, unknown si L and C. And our RO, di ba si RO is equal to square root of L over C. If we're looking, so kung hanap natin sa capacitor, we'll solve this in terms of inductor, and substitute natin dito, we're gonna have capacitor and FC, which is given sa FC, so mahanap natin si capacitor. So kung hanapin ko si inductor, that would be RO square L over C. So my L would be equal to RO square times C. Substitute natin na siya din here. We're gonna have 1 over pi square root of L would be this one. RO square C times C. Cancel class ang square root. And also yung C, isa na lang matitira. So you're gonna have FC is equal to 1 over pi RO C. Okay? And since given na si FC and RO, then we can look for our C. So our C in this case would be 1 over pi RO times FC, and this is equal to 1 over pi. RO is, sabi ko kanina, that is 600. And your FC would be, this is low pass filter, so the low would be 15 kilohertz. Sorry, 15K. And that's gonna give you C, which is equal to, pause the video and try to calculate. This is equal to 35.37 nanofarad. So this is your C. Class, itong C na to, that is only for low pass filter. Okay? Diba remember, this is C, this is L over 2, L over 2. Okay? So we now have our C, which is equal to 35.37 nanofarad. So using the formula ni RO, we're gonna look for our L. So si L daw is equal to RO square times C. RO is 600 square times C, which is 35.37 nano. And you're gonna have L, which is equal to 600 square times 35.37, 12.73 millihenry. So that is your L. So yan, ito na si L. So ibig sabihin, this one here is L over 2. So if we, that is our L. If our L is 12.73 milli divided by 2, so you will have here 3 point. So itong value natin dito would be 3.36 millihenry. And same is true sa kabila. This is also 3.36 millihenry. Yung capacitor, that's 35.37 nanofarad. Okay? So you check this PDF. That is, ay ganyan yung solution sa PDF that I'm gonna give you. Okay? So that is for your low pass. For high pass, same procedure is done. However, you just have to be reminded that yung ating FC is iba na. Still, ito pa din naman yung mga given. Ito na yung focus natin. So, for high pass filter, yung ating FC is equal to 1 over 4 pi square root of LC. And still, RO is equal to square root of L over C. Same kanina, simplifying this one, we're gonna have L is equal to RO square C. Substitute dun sa kabila, FC would be 1 over 4 pi square root of L, which is RO square C times C. Cancel ang square root. Cancel ang square. This one becomes C. So your FC is equal to 1 over 4 pi ROC. So C is equal to 1 over 4 pi RO FC. Okay? So given na itong ating FC, this is 1 over 4 pi. RO still 600. Yung FC natin, high pass, this one na. Kanina, that's 15. Now, we're gonna use 10K. This is 10K. So, yung capacitance natin would be, this is 1 over 4 pi times 600 times 10K. Then, you have 13.26 nano. 13.26 nanofarad. Okay. Now, take note because this is high pass filter. Diba this is 2C, this is L, this is 2C. So, if this is our C, then we would have here, ang value ng ating capacitor dito would be, ito siya, times 2, which would give us 26.5 nano. So, this is 26.5 nanofarad. Same is true sa kabila. 26.5 nanofarad. Now, we're looking for L, which is easy na kasi we have this formula. Based on that, our L is equal to RO square times C. Given na si RO, that's 600 square. Yung C natin is na-solve na kanina, which is 13.26 nanofarad. So, our inductor would be 600 square times 13.26 exponent negative 3. That is going to be 4.77 millihenry. So, ibig sabihin, class, sa circuit na to, we're gonna have 4.77 millihenry. And this is your bandpass filter. Ito na yung mga values niya. So, ibig sabihin, if you're gonna make a circuit na ito yung values na ilalagay mo, then you're gonna have an output impedance of 600 and yung cutoff mo, class. So, kung titingnan natin, diba, this is your attenuation, this is the frequency. Kumbaga, ito, attenuate siya dito, will not attenuate, and then attenuate. So, ito, class, this one here is 10 kilohertz, and this one is 15 kilohertz. Okay, so attenuate siya dito, attenuate dito. This one is the bandpass. Okay, it will not attenuate these values. Right, so that is our example. Now, for the last type of filter, we have, last filter would be the band stop filters. So, a band stop filter is one designed to pass signals with all the frequencies except those between the two specified cutoff frequency. So, parang ano lang siya, baliktad siya kanina. Diba, if sa band pass filter, so, ba yun si band pass? Kung si band pass, ganito siya. Ito sa gitna, ito yung pass band natin. Si band stop, if you notice, class, yung attenuation natin, attenuation band, is nandito sa gitna. Okay? But, the rest, it will pass. Ito yung pass band natin, but sa gitna, it would attenuate. Kaya ganito siya. Okay, it would pass this one, and will attenuate itong sa gitna. You still have FCL, and your FC high. So, kung titingnan mo yung symbol, class, you have dalawa. You have, parang mayroong tatlong region ng iyong signaling. Sa gitna, class, yun yung isa-stop niya, or i-attenuate niya. That's the band stop filter. So, how is it done? Sino din naman kanina, this filter can be performed by connecting a high pass. Meron kang high pass, and the low pass. Same pa din siya, in parallel. As can be seen for a band stop filter, so yung FC high pass mo is greater than FC ito, low pass. Ito na din yung consider natin. Kanina baliktad, diba yan? Then the stop band being given by the difference between these values. So, kung kukunin mo tong stop band mo, it would be this one minus this one. Okay? So, that is the last type of filter.